Okay, we are going to actually start Chapter 1 with Section 1.3. We're going to skip Sections 1.1 and 1.2 because those are tidbits of information that you can actually just read and understand on your own. Things that you should probably learn before you get into this class. For instance, Section 1.1 is about what chemistry is. Section 1.2 is how to use the book. So we're going to skip those two chapters and let you read them on your own, and we'll jump right into Section 1.3. 1.3 introduces measurements to the book. For instance, we have 8:30 a.m. That would be a measurement of time. We have 165 centimeters. That is referring to the girl's height. They also say 65 inches. That's meaning that these two things are the same. They do that to reinforce the fact that even though things have different numbers, if they have different letters at the end of it, that means that they have different units, which means that they're measured differently. But they are equivalent. So when we start talking about measurements, scientists use both the metric system and the International System of Units, which is also called SI units. Metric system has been around a lot longer than the SI units have, and so that's why, especially biologists use this more than chemists or physicists. For instance, when we talk about biological functions, a lot of times they'll talk about degrees Celsius. SI units, however, is a system that's been derived by scientists specifically so that they can communicate throughout the world and all refer to the same units. And they are the same probably about 60% of the time or so, but there are some differences that you'll have to be aware of. For instance, if we look at length, both SI and metric are meters. However, if you look at volume, metric is liters, but SI is meter cubed. So those are the kinds of differences you'll have to be aware of for grams versus kilograms, degrees Celsius versus kelvins. This, you're going to have to take the time to memorize, make flashcards on that, just to know what the SI units and what the metric units are. I am primarily going to be concerned with the SI though, so make sure to memorize at least the SI. Now we're going to talk about how they relate. For instance, here's 1 inch on a ruler. Just because it's measured in centimeters up here doesn't mean the actual distance has changed. There is a bit of a difference between both the metric and the English. But these are called conversion factors. Or equivalences. So therefore, we can actually start using those when we start doing conversions, which will be during the next lecture. But something equal to something else. So that's why 1 inch is 2.54 centimeters. Here's 1 inch on a English ruler, on a yardstick. If we actually measure the yardstick with a meter stick, that's where the 1 inch would lie. And that's where we get the 2.54 and the 1 inch. Once again, here's some more equivalences. Notice that they're using the graduated cylinders to measure volume. I've seen people do this in lab. They've actually put the graduated cylinder on top of the scale. The problem with that is you could actually end up breaking the scale. So you do not want to do that in the lab. If you're measuring volume, you specifically want to use the graduated cylinder. And same with the scale. If you're measuring something in grams, you want to use the scale. You do not want to use it for measuring volume. You don't want to put a beaker on top of it. You don't want to put a flask on top of it. That's why we have these weigh boats. So here's some more conversion factors for you. 1 kilogram is equal to 1,000 grams. Anything that's not metric, I'm not going to make you memorize. I'm going to provide those on a test itself. However, you do need to know what your prefixes are, which we're going to talk about that later on. We're actually going to spend quite a bit of time now talking about temperature, because there's actually 3 different scales for temperature. We have Fahrenheit here, we have Celsius here, and we actually have Kelvins. So we have 3 different temperature scales. Fahrenheit is an English unit, which actually only the US uses Fahrenheit. So if you ever travel outside the country and you are listening to the news, you might hear something like it's saying 27 degrees. Well, they're referring to degrees Celsius, they're not referring to degrees Fahrenheit. So it could still be summertime when it says, it will be summertime if they said 27 degrees Celsius. This is the metric. And this is the SI unit, is kelvins. Alright, the measurement of temperature is just determining how hot or cold an object is compared to something else. Remember that heat always flows from higher temperature to lower temperature. The molecules are moving fast when it's hotter. They're moving faster. And so they're going to basically start merging or start the slower moving molecules moving faster. And that's how you indicate, that's how the heat gets transferred. So if we take a look at a direct comparison between the 3 scales, we have Kelvin, Celsius, and Fahrenheit. If we look at where water starts to melt, where ice melts, that's 0 degrees Celsius. When they first decided to come up with a temperature scale, they wanted to relate it to something that everybody could relate to. And that is where they came up with 0 degrees Celsius, because that's where water starts to melt, and that's something that everyone could be related to. And then they decided to go ahead and make temperature boil at 100 degrees, because once again, that's something that everyone can relate to. It was related to water. If we come over here to the kelvins, just to the left of it, you'll notice that 0 Celsius is the same thing as 273 Kelvin. 100 degrees Celsius is 373 Kelvin. There's a difference of 100 degrees here between 0 Celsius and 100 Celsius. 273 Kelvin and 373 Kelvin. Either way, it's a difference of 100. The scientists related kelvins very closely to Celsius. The main difference is that 0 degrees Kelvin, that is a scientifically determined temperature, rather than mathematically determined, rather than something that they can visualize. What they've discovered is, the theory is they predict that at 0 Kelvin, which is also called absolute zero, matter would completely stop moving. So all the vibrations that you've been taught all through your life, where even though something is solid, the particles are still moving inside, all those vibrations would stop at 0 degrees Celsius in theory, 0 degrees Kelvin in theory. Therefore, this has not actually been proven yet. This is what they have mathematically determined. They've gotten really close, but they haven't actually gotten quite there yet. But they've gotten down to like 2 or 3 Kelvin, so they've gotten really close. Now, on the right-hand side, you'll see Fahrenheit. Fahrenheit is only for the U.S. People don't usually use Fahrenheit anymore. In fact, if somebody comes into the country, they're usually really confused by the different unit scales that we use. But you notice that there is 100 degrees between Celsius and from 0 to 100 Celsius. There's 180 between 32 and 212. That is going to become relevant in about 5 seconds when we start determining how to convert back and forth, because in order to talk to other people in other countries or to be able to communicate for one reason or another, we need to be able to do that. So let's take a little review. I'll give you a minute to read these questions. Okay, what is the temperature at which water freezes? That would be 0 degrees Celsius. 0 Kelvin is absolute zero, and that is the temperature at which everything stops moving. And 0 degrees Fahrenheit doesn't mean anything, but if we change that to a degree Celsius, it would have. What is the temperature at which water boils? 373 Kelvin. This is where water freezes. If this would have said degrees Celsius, we would have been fine. And how many Celsius units are between boiling and freezing points? Right here, 100. 180 is 4 degrees Fahrenheit. And 273 is how much you have to add to convert it from Celsius to Kelvin. That's the difference between Celsius and Kelvin. And there's the correct answers. Alright, so I had stated before that there's 180 degrees between boiling and freezing of water. Right here. And there's 100 on the Celsius scale. So from that information, we can figure out how we're going to convert it. So 180 over 100 becomes 9/5. It's easier to keep it in a decimal, to reduce it down to a decimal rather than keep it in a fraction. People get confused with the fraction when it comes to the actual calculation of it. So it's easier just to keep it in the 1.8. And then plus 32. Water freezes at 0 Celsius but 32 Fahrenheit. So even though we have this big difference of 180 versus 100, we have to add another 32 to it. Alright, so let's do a couple practice problems. Hypothermia may occur when a body temperature drops below 35 degrees Celsius or 95 degrees Fahrenheit. A person with hypothermia has a body temperature of 34.8 degrees Celsius. What is it in Fahrenheit? So, in order to do this, we have T degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32. So Fahrenheit is equal to 1.8 times 34.8 plus 32. I'll give you a minute to put that into your calculator. So that comes out to be 62.64 plus 32 is equal to Fahrenheit. And degrees Fahrenheit would then equal to 94.64, which, if you notice, is actually, once again, below 95 degrees, which is what they said it would be. We'll try another one. We have negative 15 degrees Celsius, and we're converting over to Fahrenheit. So Fahrenheit, once again, is 1.8 degrees Celsius plus 32. So Fahrenheit is equal to 1.8 negative 15 plus 32. So give you a minute to put it into your calculator. Negative 27 plus 32. That is then equal to 5. There you go. Now let's reverse the order. Now we're going to have a normal body temperature of a chickadee is 105.8 degrees Fahrenheit. Now we're going to go in the reverse order. What is it on the Celsius scale? So 105.8 is equal to 1.8 times the temperature in degrees Celsius plus 32. Rather than multiplying first this time, we're going to subtract first. So go ahead and put that in your calculator. And it comes out to be 73.8 is equal to 1.8 degrees Celsius. Temperature in degrees Celsius. So we're going to divide both sides by 1.8. And that comes out to be 41. Now it comes out to be a whole number. Oh, that's right. It's 41. We'll talk about significant figures later. Alright, so we have degrees Fahrenheit now, and we're talking about pizza. And we're going from Fahrenheit to Celsius. So 455 degrees Fahrenheit is equal to 1.8 times the temperature in degrees Celsius plus 32. Once again, first thing we want to do is subtract 32. That comes out to be 423. Divide both sides by 1.8. And that comes out to be 235. Finally, the temperature scale for Kelvin is actually a little bit easier than Fahrenheit. Because the Celsius and the Kelvins change at the same points, for instance, the difference between freezing and boiling is 100 degrees Kelvin and 100 degrees Celsius. It's a 1-to-1 ratio. Because of that, it makes the calculations really easy. All we have to do is add 273 because the starting point, if we look at the water, the freezing point of water, it's 0 degrees Celsius, but it's 273 Kelvin. So because of that difference right there, we have to add 273. Okay, just to give you some examples of different temperature scales. A hot oven, 450 degrees is what we're used to saying when we read a recipe. However, if you're reading if you're want to be a gourmet chef and you're reading a French cookbook, you might actually see 273. But that's equivalent to 505 Kelvin. Room temperature is another one. Room temperature is 70 degrees in the US, but everywhere else it's 21. In the scientific world, it would be 294. Alright, so we have the normal body temperature is 37 degrees Celsius. We want to know what it is in Kelvin. So degrees Celsius, Kelvin is equal to degrees Celsius plus 273. So Kelvin is equal to 37 plus 273. Which comes out to be which comes out to be 310. That looks like a 4. 310. Okay. So before we go on, let's take a minute to have at least one thing in your notes going from degrees Fahrenheit to kelvins. You'll notice that there's not one equation to do that. So in order to do this, you have to go from degrees Fahrenheit to Celsius to kelvins. So for instance, if I say you were taking somebody's temperature and they had a fever of 102 degrees Fahrenheit. However, a scientist came in and needed to do some experiments on it, so they need the number in kelvins. So first thing you need to do is convert this over to degrees Celsius. So 102 is equal to 1.8 degrees Celsius plus 32. Subtract 32 from both sides. That comes out to be 70 is equal to 1.8 degrees Celsius. And that comes out to be 38.9 degrees Celsius. But we need it in kelvins. So we have kelvins, this is separate. Kelvins is equal to 38.9 plus 273. That comes out to be 312. I wanted at least one example in your notes going from all 3 units. Alright, I'll give you a minute to think about this question before we answer them. Alright, so SI units. Remember, SI is not the same thing as metric. They're 2 different things. So volume for SI is actually meters cubed, whereas metric is liters. Mass for SI is kilograms, whereas metric is just grams. So if you got those 2 and you were thinking they were SI units, make sure you go back and you make flashcards to memorize that. Length is meters and meters, so those are the same. Temperature, SI is Kelvin, and metric is degrees Celsius. Okay, that is all of section 1.3. The temperature stuff is actually in chapter 2. It's the only thing we're going to be doing in chapter 2 this semester. So that is the end of this particular lecture.